According to the Big Bang Theory, we know that our universe is steadily expanding. The speed of this phenomenon exceeds even the speed of light. But what is at the edge of the universe, and what can be understood by the definition of the edge of light? A black impassable wall, an abyss, infinity? Scientists have tried to answer these questions, and today we will tell you about their conjectures. Sean Carroll, professor of physics. The universe has no boundaries. We can only talk about the edge of the observable universe. That's the maximum distance we can look at from Earth. If the expansion of the universe continues indefinitely, we won't be able to see its end, even if it exists. Because when we look at the most distant stars and planets, we see their echoes from the past, as light travels at the same speed. All objects at the end of the observable universe appear to us as they were almost 14 billion years ago. Still, this cannot be called the physical boundary of the cosmos. Our view into space is limited by the power of modern technology, and we cannot look beyond the edge of the observable universe. And there's a vast expanse of space beyond too. All that we observe is fairly homogeneous space, and it's likely to continue to be so. The universe may turn out to be in the form of a sphere as an option. In that case, space would be limited, but still have no physical boundaries, because a sphere has no beginning and no end. Also, we cannot discount the multiverse theory, according to which the cosmos is not homogeneous and can change greatly in some regions. So far, we can prove neither. So now, it's wise to remain neutral and not to give preference to any of the theories. Jesse Shelton, Associate Professor of Physics and Astronomy. Wanna know what's out there at the end of the world? First think, what do people mean when they talk about the edge of space? The speed of light doesn't change, so the more outer space we see, the more we go back in time. Just look at the Andromeda Galaxy, the closest galaxy to us. We see events from the past that took place about 2.5 million years ago. That's how long it takes for the light from the stars of this galaxy to reach us. The oldest light we have ever seen came to us from the farthest reaches of the universe, so metaphorically, we can think of it as the edge of space. These are echoes of the Big Bang, the beginning of time, the very moment when space cooled down so much that atoms began to form in it. This phenomenon is called the surface of the last scattering, the place and time when the photons of light from the hot plasma moved into the cold vacuum, in which they began their movement into distant space toward our planet, where we saw them. Therefore, the surface of the last scattering can be called the edge of the universe. So what's happening at the end of the world today? Unfortunately, we don't know that, and we will never know. Because even if right now, light from there went our way, it will be billions of years before it reaches us, so we can only speculate about it. Based on what we're seeing in space right now, it's likely that the same thing is happening out there at the edge of the universe right now. If we were there now, you probably wouldn't even see much difference. The edge of the universe is not the end of the universe, but an extension of it. There are even more stars and galaxies, and perhaps life forms, facing the same question now. Abigail Wareg, Associate Professor of Cosmological Physics, writes the following: with Earth's telescopes, you see light coming from the depths of space. The farther those depths, the longer we will wait for a signal from them. So when you look at distant stars, you see what they looked like a long time ago, not what they are today. The longer you look at them, the further in time you move. and you look until you see almost the very beginning of time, a few thousand years after the formation of the universe. But alas, you can't look any further, because before that, the universe was incredibly hot and dense, and there were no stars, no planets, not even atoms. Photons of light were just bouncing back and forth in that hot plasma, trying to get a hold of something and fly out of it. Not even the most advanced telescopes on Earth would allow you to see that. That's why it can be called the edge of the universe, the observable universe. Simply put, it's the horizon. After all, we can neither see what is happening beyond it, nor even get close to it. However, even that has no power over time and the expansion of the universe, so it's constantly shifting. If we had the opportunity to see the universe from any other planet, most likely we would observe the same space, with the same stars, which ends only where time begins, limited by the speed of photons, flying to us almost from the Big Bang itself, and of course, by the expansion of space. How do we see this horizon? Probably we can't. We can only see what it was after the Big Bang, but not what it is now. However, research results anonymously shout that the entire observable universe looks roughly identical. It's all the same stars, galaxies, and the cosmic vacuum. The universe is much more vast than the tiny slice we can see from our planet. Therefore, there's most likely no edge to the universe. There's only space-time, which is constantly increasing in size.